All right, so this review is over units 2 through units 4. Let's get started. First topic, we're going to talk about our functions, okay? What defines a function? In order to be a function, okay, each input must have exactly one output. I always like to think about a gumball machine. If you input a quarter into a gumball machine, only one gumball should pop out. If you were to input a quarter into the gumball machine and the entire thing came out, right, it would not be functioning. So there are different ways that you can check to see if something is or is not a function. We could look at this list. Okay, when your input 1, your output was 2. When you input 2, your output was 3. And when you input 3, your output was 4. So this one is a function. Each input has exactly one output. However, in this example, when I input the number 1, my output was 4 and my output was 2. Okay, this is not considered a function. Okay, there was an input that had more than one output. Okay, or you can check to see if it passes the vertical line test on a graph. Okay, if you look at this, I can use my pencil as the vertical line. Okay, I can just scroll through. If my vertical line intersects the graph in more than one spot, it is not a function. Right, for example, vertical line here, it's intersecting only once. Vertical line here, it's intersecting only once. All right, so every single where I go, okay, it's passing the vertical line test. So yes, this is a function. All right, down to naming polynomials. Okay, one thing I want to talk about naming polynomials, it needs to be in standard form. So right now, this is not in standard form. We could rewrite it by going from the highest exponent all the way to the lowest exponent. Again, let's write this one in standard form. I'm going to start with my highest exponent. Next one, and then no exponent or the constant at the end. Okay, we're going to name each polynomial by the number of terms and the degree. Okay, this has two terms. Terms are separated by plus and minus signs, so this would be considered a binomial. Okay, then the degree is 1, right? The degree is what your highest power is. So this is a linear function. This would create a straight line, and there's two terms, so a linear binomial. Okay, this one has 1, 2, 3 terms, so that's a trinomial. The highest degree is 2, so this is a quadratic. This one would make a line. This one would make a parabola because it is quadratic. Highest power is 2. All right, we can evaluate functions either on the graph or with in a given equation. Okay, this is read as f of x. Okay, it's a fancy way of writing y. Okay, so instead of using y, we're just using function notation. Okay, what's nice about function notation is you can see what you are plugging in, right? So this one I'm plugging in 2. This one I'm plugging in -2. So you can see what your input is, and then you can find your output. So if I input 2 into f of x, f of 2, that'll be 2 squared minus 2, which that's 4 minus 2, which is 2. I can input -2, -2 squared minus 2. Well, -2 squared, that's a positive 4, right? Because negative times a negative is a positive. So this would also be 2. This I'm inputting into h. So h of 2, let's see, we have 2 cubed minus 3 times 2. See, 2 cubed, 2 times 2 is 4, times 2 is 8. So that's 8 minus 6, which is 2. Last but not least, input 1. 1 cubed minus 3 times 1. Let's see, 1 times 1 times 1. That's still 1. So 1 minus 3 gives us a -2. Or we could evaluate functions looking at the graph. Let's see what happens if I input -3. Well, that's -1, -2, -3. When I input -3, my output was +3. When I input 1, my output was 4. All right, adding and subtracting polynomials. Okay, don't forget to distribute the negative when you are subtracting. And remember, you must add like terms to simplify completely. So, first thing I'm going to do is I'm going to distribute those. Negative 2 minus 8x plus 3x minus 18. Then we can combine like terms. Okay, so we have negative 8x plus 3. That would give us a negative 5x minus 20. Next one, let's distribute. That'd give you negative 6y plus 6x plus 6 minus 24x. We can combine like terms and write it in standard form. Remember, standard form is going to be highest to lowest exponent and alphabetical order. So we could do negative, let's see, negative 24 plus 6. That would give us negative 18x minus 6y plus 6. So this is standard form, alphabetical, and highest to lowest exponent. All right, last one or last section, we have a subtraction, we have an addition. With subtraction, you have to distribute the minus sign. Giving you x squared minus 2x plus 3 minus 4x squared minus x plus 2. Let's combine like terms. All right, that's going to give us, let's see, 1 minus 4. Negative 3x squared, negative 2 minus 1, negative 3x, and that would give you a 5. All right, with addition, distributing a positive 1 will not change any of the signs, so you can just code the like terms and let's combine them. That'll give you 5x squared minus 3x, and negative 25 plus 12 would leave you with a negative 13. There we go. All right, talking about arithmetic sequences, okay, what's nice is that these formulas are on the EOC formula sheet, so you don't have to memorize them, you just have to know how to use them. An arithmetic sequence is when the pattern is that you're adding something consistently. So let's see, it looks like we are doing, let's see, plus 6, and plus 6. So this is an example of an arithmetic sequence because you are adding 6 every single time in the pattern. So if we wanted to continue the pattern, you could add 6 again, giving you 30, giving you 36, and giving you 42. So it is arithmetic. We can find the common difference. The common difference, or D, is 6, and we found the next 3 terms in the sequence. Let's do the same thing right here. Let's see, it looks like to go from 160 to 80, we had to have subtracted 80 or added negative 80. But now it looks like we added negative 40, and then we added negative 20. We're not adding the same number every single time. I actually feel like this is a geometric one where you're multiplying by 1/2 times 1/2 times 1/2 times 1/2. So not arithmetic. This is actually geometric because you were multiplying by the same value every single time. All right. For the following sequences, find A sub 1 and D and state the explicit formula for the general term. Okay. Well, A sub 1 is the first term in the sequence. So there's A sub 1. Your D value is what you're adding by every single time. So it looks like for this one, looks like we added 6, added 6, added 6, added 6. So my common difference is 6. For this one, it looks like you are adding a negative 5, or basically subtracting 5. So negative 5 is your common difference. Now, they said they want us to write the explicit formula, so make sure you pull from the explicit formula, not the recursive one. And let's plug it in. A sub n equals my first term plus my common difference times n minus 1. Same thing down here. A sub n equals the first term plus my common difference times n minus 1. If you wanted to write that as just minus 5, that's perfectly fine too. All right, write the formula with the given information and find the indicated term. So they're telling me a sub 1 and d. So let's write my formula. It's a sub n equals my first term, okay, plus my common difference times n minus 1. If you wanted to simplify this, you can. Okay, simplifying it would require that you distribute. These positive 46 and negative 46 would cancel out. And now I want to find the 46th term in the sequence. So I'm going to plug in 46 for n. So a sub 46 is equal to 46 times 46. So it looks like the 46th term is 2,116. You could simplify these as well. In order to simplify them, you would just need to distribute and then combine like terms. So again, you could always simplify the explicit rule by distributing and simplifying or combining like terms. All right, combining like terms is your last step, okay? So here we go. They want us to take f of x and add it to g of x. So f of x, that's 2x plus 4 plus 4x minus 10. You can combine like terms, giving you 6x minus 6. For this next one, be careful because you're subtracting. So it's this function minus all of g of x. So you're going to need to subtract the first term and subtract the second term. So that just changes the signs. That would give you negative 2x plus 14 as your final answer. Next, they want us to multiply this function times this function. Well, that's a binomial times a binomial, so you're going to have to distribute. So 2x times 4x, that's 8x squared minus 20x plus 16x minus 40. The last thing you can do is combine like terms. So 8x squared minus, 4x minus 40 would be your final answer. Okay, last but not least, they have both multiplication and division. So we're going to multiply f of x by 2 and add that to multiplying h of x by 3, which h of x is just negative 3. So we plug those in. Let's get to work. Distribute, giving you 4x plus 8. 3 times negative 3, that is negative 9. So 4x minus 1 would be your final answer. Okay, Andre has a regular savings account that has $250 in it. Each month he adds $45 to it. He is also saving to go to Europe. He deposits $100 to start the account and decides to deposit $60 each month. Write a function to represent the prices R of X for Andre's regular savings account and E of X to represent Andre's European savings account. So R of X, he is doing $45 per month plus the $250 that's already in the bank account. E of X, he is doing $60 per month and already has $100 in the savings account. We're going to combine the two functions to add them together. So 45x plus 250 plus 60x plus 100. That would give you 105x. So he's saving $105 total a month, and he already has a total of $350 saved. Last thing we're going to do is calculate, but I will do that in the next video.